Okay, so we're going to start with the worksheet that you sent me um, regarding the sample ideal gas law problems. The first problem we're going to look at will be number 2 from that packet. And I'm just going to read that problem. It says, what volume is occupied by 11 grams of carbon dioxide gas at 25 degrees Celsius and 371 torrs? Okay, so right away, I'm sure you probably guessed it. What we're looking for in this problem is the volume. So we'll start out by writing the ideal gas law problem. Okay? So we have PV, or pressure times volume, is going to be equal to N R T. N is going to be your number of moles, or the amount of sample. So when we think about N, the best way to think about that acronym is to associate that N with number. So this is the number of something. Then we have R, which is always going to be our constant. And as I told you before, our constant will always be based off of our pressure. So we will pick a constant depending upon the units that our pressure is in. And T is always going to be related to temperature. And I think the last time we spoke, I talked to you about the moment you identify from the problem what it is you're trying to solve for, rearrange your ideal gas law equation in a way so that you're solving for what you're looking for. In this case, we're looking for volume. So automatically we see that we're multiplying pressure times volume, and we have it equal to the number or the amount, in this case of carbon dioxide, times a constant times a temperature. So all we have to do to solve for volume in this case is divide by pressure, right? So if we rearrange this equation, we'll say volume is equal to nRT divided by P, okay? So by doing this, we eliminate having to figure out which goes where, how to rearrange it. If we do it automatically in the beginning, we won't have any problems knowing where each of these items go. So let's move on into filling in these variables with the numbers that are provided in this particular problem. Okay, so we start out with 11 grams of carbon dioxide. And again, if we look at our equation, N is going to be number is an amount. So we have an amount of carbon dioxide. In this case, it is going to be 11 grams. So let's write that. So we have 11 grams of carbon dioxide, otherwise CO2, which would be the chemical formula. We know that N is always going to be in moles. Always going to be in moles. Can't use grams. Easiest way so we know we have to convert this 11 grams into moles in order to use it in this particular equation. So this goes back to all of the conversions that we did first semester, which were your favorite. So we draw a fraction line. We know we have to go from grams to grams so that these two cancel out. And then we will have 1 mole of CO2, right? And anytime we're going from, we're trying to go from grams to moles, we want to divide by the atomic mass of this chemical compound. We know that if we pull out our carbon, if we pull out our periodic table, we know that carbon is 12. We have 1 carbon. And then we have oxygen, which is 16. We have 2 oxygens. So 16 times 2 is 32, plus 12 is 44. So we know we have 44 grams of CO2, right? And automatically we know that we're going to be left with moles because grams does what? It cancels out. So we end up having 11 divided by 44. Okay, let's see. Let's do the math on that. We get 0.25 moles, right? So let's say 11. Yeah, we get 0.25 moles. Next up, if we're still looking at number 2, we are given temperature and pressure, right? Let's look at pressure first, since we have to do a conversion with pressure. Pressure, it gave us 371 torrs, right? Now, torrs, there's only 3 things as it works for the ideal gas law. It can either be in ATMs, millimeters per mercury, or kPa. This doesn't fit into that bracket, so that we know that we're going to have to figure out what is our conversion for this. Well, if we put this, I'm going to put this over to the side. We know that 1 torr is equal to 0.00131579 ATMs, right? So we know that this is going to end up being a smaller number when we do the conversion to ATM. So let's do that, okay? Now, if we divide by this small number, we know that we'll only make this number bigger. So we know that it wouldn't go to the bottom. So we know we're going to have to multiply. So we say 1 torr is going to be equal to 0.0013159 ATM, right? And again, in our conversions, we always want to set it up so that the units that we're converting from cancel out, so that we're left with what we're converting to, which in this case is atmospheric pressures or ATM. So torrs cancel out. We have 371 times 0.0013159, and we get 0.488. Okay, so we get 0.0488 ATMs. Okay, and that is going to be our pressure, right? Then we know that we have our temperature, and as we talked about during our last session, temperature has to be converted into kelvins. That is the only way that you can use temperature. You cannot use temperature in its Celsius form. It has to be converted into kelvins. So for this problem, we have 25 degrees, right, in any time. So we have 25 degrees Celsius. Anytime we're trying to convert to kelvins, we always add plus 273. And that will automatically convert this into kelvins. So we say 25 plus 273. That gives us 298 kelvins. Okay, and kelvins is its variable is denoted by a K here. So now we can go back. I'm going to circle it. Now that I have all of this clutter, we can go back and plug all of this into this problem, because we rearranged our original ideal gas law equation so that we were solving for volume, right? So now we still don't know what our volume is, so that is going to be V. There's my cap. V is equal to N, which we determined N after we converted 11 grams of carbon dioxide into moles. We determined that that was 0.25 moles. Let's write that. Okay. Our constant, now that we have converted our 371 torrs to ATMs, is going to be our ATM constant, which is 0.08 2, right? And then our temperature, once we converted our 25 degrees Celsius by adding our 273, we got 298. And all of this is going to be divided by our pressure. Remember, we had to convert our pressure, our 371 torrs, into ATMs. And once we did that, we got 0.0488 ATMs. Let's do the math on it. Let me pull out the trusty calc. So we have 0.25 times 0.082 times 298. We're going to divide all of that by 0.0488. And we get 125. 0.25 times 0.082 times 298 divided by I made a boo-boo. Okay. So now we say 0.25 times 0.082 times 298 is that divided by 0.488, and we get 12.5 liters is our answer. Okay. Yeah. Yep. So this is what we get. We get our volume to be 12.5. Okay. 12.5 liters.